Radix Sort is a non-comparative integer sorting algorithm that sorts data with integer keys by grouping keys by the individual digits which share the same significant position and value. This is our input list of numbers. I have taken 8 numbers to show what exactly radix sort entails. So I have 100, 54, 355 and so on. I have 8 numbers, integers. So to start off, so radix here we will take as 10. Radix sort uses the concept of buckets. Buckets are nothing but holders of values. And when we have to sort the numbers based on individual digits, then we make use of buckets to put them in a particular order. Let me show you to so that you understand better. Decimal or radix equal to 10 has 10 digits 0 to 9, and to arrange these digits in the correct order we will place them in their respective buckets. So radix sort is also a type of a bucket sort, which is a separate sort, and I'll cover it in a different animation tutorial. But for the time being, so we have 10 buckets, and then as you see the input list we have, so for 100 the ones place is 0. So we keep moving from left to right. The next number we pick is 54, then we pick 355. As you see, the we are considering the ones place. 355's one place is 5, so it goes into the bucket of 5. 54 is 4, 43 is 3, and 102 has ones place value as 2. So like this we put all the numbers in the respective buckets, and now comes the interesting part. So at this point we have put numbers into individual buckets as per their ones place. Now we retrieve the numbers and we maintain the order in which they were put inside a specific bucket. So if 100 was placed before 10, we pick 100 first and then 10. Similarly for ones place 5, we pick up 355 first and then we pick 5. And we pick up values starting from the bucket number 0 and moving rightwards toward the bucket number 9. So 10, 102, 43, 54, 355, 5 and 287. So if you notice closely in the numbers I am encircling, that you see the ones place in these numbers. So 100 has ones place as 0, 10 as 0. So the value at ones place is increasing as you move towards the right. Okay, keep this in mind. And then we move on to the next phase of the sorting, which is where we sort the numbers as per their tens place. And we maintain the order which we have got just now. So it's we have arranged the elements in their ascending order as per their ones place, and we will use this list which I have encircled in the next phase. So we bring all the buckets down. These are the buckets for every individual digit. So we have 10 buckets, and then I start adding the numbers as per the tens place. So 100's 10 place is 0, 102's is 0, 10 has the tens place as 1, 43 has 4, 54 and 355 have 5, and 5 has tens place as 0, 287 has 8. So now, just like we did in the case of the ones place, we again pick up the values from the left. in the same order in which they have been put in the bucket, and pick up values from all the buckets in the increasing order of the tens place value. So now we have the numbers sorted as per tens place. Now observe closely here, just like in the above case, the above circle, you see the ones place values were sorted in increasing order. In this below circle, the tens place values are sorted. Now we move on to the third phase, which is sorting by the hundreds place. So what we need to follow as a thumb rule is that the number of phases or iterations of the algorithm will depend on the maximum number of digits in the list. So in this case, the maximum number of digits is 3. So we need 3 passes. The last pass will sort our semi-sorted list currently which we have now as per the values in the hundreds place. So let's go ahead and bring the buckets down similar to the way we brought it earlier. In our program, which we will write later, we reuse the same buckets. So it's kind of metaphorically showing the same thing. Anyway, so now 100 and 102 have 1 in the hundreds place. 5, 10, 43, 54 have 0 in the hundreds place. 355 has 3 and 287 has 2. Now we pick the values from the left and the right, again maintaining the order in which they were inserted. And so we get 5, 10, 43, 54, 100, 102, 287 and 355. And this is our sorted list. This list is sorted by the hundreds place, by the tens place and the ones place. And this is the final sorted list as per Radix Sort. So next I will show you the Java code for this Radix Sort algorithm which we just saw in action. So we start by defining the class which will contain the code for Radix Sort. We'll name it Radix Sort. And then we define our public static void main method because we intend to run this class itself to do the sorting. This is standard public static void main, as you know. Next, we prepare the input array. Input array contains the elements which we will be sorting. I have used the exact same integers which I have showed you in the whiteboard animation video just a while back, so that it's easy to comprehend what we are doing. Our radix is 10. So this algorithm, so that you know in advance, can work for radix equal to any value. We just need to replace 10 with a particular radix and it will work. The only point is that the input array should contain values as per that radix. So we have array list for every bucket and we have an array of these buckets of size radix because we have 10 buckets. Next what we do is we initialize each and every bucket, which is nothing but an array list, by assigning it a new array list of integers. So now we have our buckets ready to fill in the numbers. Now next we define a boolean value which is nothing but our indicator to come out of the passes loop. So as you remember, place value currently we have taken 1 because we are going to sort the digits in the ones place. And while our indicator remains false, we keep iterating. So inside we make it true so that by default it's true unless we set it as false. So next we are going to see the logic of how we pick up the individual place value digit. So temp is equal to element by place value. Say the element is 287. So place value currently is 1 as we set above. And buckets array of temp percentage radix. Temp as we saw is 287 modulo radix which is 10. So our remainder is 7. So 287 goes into buckets array number 7 which is correct. So the moment we reach 4 digits, and we know that all our numbers are currently 3 digits. I mean the algorithm doesn't know but we know. So in the fourth number, the remainder of temp percentage radix will go below 0. And so our max digits length reached, which we had set true earlier, will remain true. It won't become false. Once we have done that loop, we come out of the loop since we have covered all the elements, and now we take out the elements from the bucket as we were doing and place them inside the input array again in the order in which they were placed in the buckets. And then we clear the buckets array. That is, delete all the array lists inside it. And then we increment the place value by doing into 10. So now we will be at the tens place. From here, our loop will continue. We will cover the tens place, similarly the hundreds place, and after the hundreds place, our max digits length reach will be true and we will come out. In this way, our place value digit keeps increasing, digits keep filling up inside the buckets, and then we take out the values from the bucket sequentially and put them back in the input array. At the end of 3 passes, our input array will have elements in the correct sorted order as we saw in the whiteboard animation video. If you want to see the logic again and match it with the code, you can go to and fro in the video, of course. I hope you liked the video. I have tried to make sure that the fundamentals are conveyed in a very clear manner, but yet I might have missed out on something. So please feel free to comment and let me know what you feel I could have added more. And if you like the way I have presented and like the way I have explained, then please like and share this video and also subscribe to Java Brahman channel. I intend to cover most of the algorithm topics, not just the sorts, but trees, graphs, and the whole array of topics in algorithms. And I'll be covering them from a Java angle. But as you saw in this video, the first half was the fundamental and the second half will be Java. That is how I'll be doing for all my algorithms videos. Thank you.